Hello everyone, and welcome to this presentation. I'm Yukti Kopeka, and today we're diving into an important topic in object-oriented programming: the restrictions we encounter while working with core concepts like operator overloading, polymorphism, inheritance, and encapsulation. These restrictions are crucial for understanding the boundaries and best practices of OOP. Let's start with operator overloading. While it's a powerful feature that allows us to redefine how existing operators work with user-defined types, enhancing code readability and functionality, it isn't without its limitations. Specifically, there are certain operators that cannot be overloaded. These include the dot operator, which is essential for member access, and the scope resolution operator, used for scope resolution. Also non-overloadable are the pointer-to-member operator and, crucially, the ternary conditional operator. Attempting to overload these can break fundamental language mechanisms. Next, we move to polymorphism, specifically its runtime implementation. Here, we face crucial rules, particularly concerning overriding. A key restriction is that constructors cannot be virtual. This is because a constructor needs to complete its execution before an object can be considered polymorphic. Similarly, static and friend functions cannot be virtual because they are not tied to a specific object instance. Finally, for a function to be successfully overridden in a derived class, the function signature must match exactly, including the name, number, and type of parameters, and return type. In inheritance, a major challenge is the ambiguity in multiple inheritance, often called the diamond problem. This occurs when a derived class inherits the same member from two parent classes, which in turn inherited it from a common grandparent. The restriction here is not on the inheritance itself, but on the need for a solution. The ambiguity is solved using virtual inheritance, which ensures only a single shared copy of the base class is present in the final derived class. This is vital for maintaining a clean class hierarchy. Our last concept is encapsulation. The core restriction is that private data cannot be accessed outside directly. This is the entire point of encapsulation, to protect data integrity. To work with private members, we must use public interface methods, commonly known as getters and setters. These methods enforce access control and allow us to validate data before it's modified. In conclusion, OOP concepts are powerful, but they operate within a defined rule set. Operator overloading has its list of non-overloadable operators. Polymorphism has strict rules against virtual constructors and static functions. Inheritance can be complex, often requiring virtual inheritance to resolve ambiguity, and encapsulation mandates access via methods. Thank you for joining me for this overview of the crucial restrictions in OOP.